Alright, hello, and welcome back to my 2.5D RPG in Unity tutorial. Today, we're going to be working on sort of like the start of an inventory and container system for the players, and containers and NPCs and whatnot. The items don't actually do anything, that'll be its own separate episode, because we'll need stuff like, I don't know, player stats and health and shit, so the items actually have something to do, but there is like a base class for items as well, just so we can demonstrate how the inventory works. So let's get on to that. So I'll just press play here. I'll have to maximise that. So you'll see on the ground there are items and shit, and if I press I, you'll see that it'll find nearby items. So there's bread and water. So let's just click this Add to Inventory button, and you'll see that it switches from the ground to the player's inventory. And we'll take some water. But also, if we go close to this NPC here, we can press I, and we can get into the NPC's inventory. So we can take their assault rifle and ammo and stuff. And there is like a finite limit. So here, see, we've got too much on us. We've reached a weight capacity, which I'm not actually displaying right now. So I should probably put that in at some point. But yeah, you can see that we've got no more capacity, so we can't take that last bit of ammo. And if we press I here, we can also drop items. So let's drop some of these assault rifles here, and you'll see it creates them in the world again. So yeah, let's go see how we did this. Sorry. Okay, so first up we have sort of the start of what will be our item class with a few basic methods and variables. So first off, we have a sprite, which is just the sprite of the object in the world. We have a texture 2D, which is basically the same as the sprite, but it's used for drawing an icon for the object for the item in the GUI menu. We've got a string for the name of the item and a float for the weight of the item. And three methods here. So the first one is create item in world. This basically just takes a position and will reactivate that item in the world. So, say, if you just passed in the player's position, it will create the item at the player's feet. It's used for, like, when we want to drop the item out of the inventory, we do that. Next up, we have add item to container, which takes this new class container that I've written, which we'll see in a moment. Basically, if the container.add items to lists with this item returns true, this will return true basically when if there is sufficient room to put the item in the container, then we return true. So if that is true, then we set the game object to not be active anymore, so it doesn't appear in the world, so it's in the container, so to speak. And then we remove the call the remove item from list from the item monitor, which is basically just saying we want to remove this object from a list of all the items in the overworld, because we don't want it to appear on like objects that we're near and whatnot. And finally, we got transfer item to a different container. And same principle, we're just taking it from one container, trying to add it to the list, and if it returns true, we remove it from the container that we are transferring it from. Okay, and also as a slight thing, weapon item has just been made a child class of this. It doesn't actually do anything, it's just so we can use weapons in the inventory as well. So this will probably be more fleshed out with like a couple of virtual methods, maybe to like define uses and say, can we use the item? Like if you've got, say, training to use power armor or some shit. So I'll be doing that in a moment. Well, I say in a moment, in a couple of episodes' time. Still some stuff I want to get done first for that. So, yeah, let's go on to containers. Okay, so this is the container class. First off, we've got the obvious thing, a list of this new item class, which is basically just all the items that are stored in the container. We've got a float for the max capacity, so that'll be the upper limit of what the container can hold. We've got a boolean to say whether this particular instance of container is the player's inventory. So in this case, it defaults to false, but on a wake we check if it's the if this get.game object tag is player, then we set it's true, and we set the public static container for the player container to be this instance. because this is me trying to sort of keep with the principle of we'll write classes and then be able to reuse them in multiple scenarios. So we can use this class for the player inventory, for NPC inventory, like chests or lockers or whatever. Yeah, and just use it in multiple instances, but with the same sort of class, so we have to write less code ourselves and it's more flexible, because that was one of the issues that came about when I developed Loud or Quiet, because I was quite inexperienced. Well, I was like 2015, so yeah, when I started it, and I've learned a lot in the 2 years of doing stuff, so hopefully my next game will be a lot better, and hopefully it'll show in these tutorial things. So yeah. Sorry, just right over. We've got a public container comparison container. This is basically just the container that we'll look at when we're moving objects between the player's inventory and a particular container. We've got a boolean for draw me, which is basically just should we draw the GUI for a container. And this, again, is just the scaling, which we use in the GUI to make sure that at any resolution, the GUI will appear the same. We don't get stuff cut off the screen. I know there's loads of, they had a GUI stuff like ages ago for Unity, so like with canvases and shit, and I've never actually used it, so I will probably try and implement that at some point instead of using this to see what it's all about and see if it's any good. And finally, we've got 4 integers: player index start, player index end, other im start, other ind end. These should be 8, not 10, but it doesn't really matter. What these numbers are is basically we have a list of items, but we only want to sample list 8 objects at a time. So this basically just defines the index where we should start looking in a list and the index where we should stop looking, and it goes up in increments of 8. Okay. So first off, as I already said, we've got the check for if this is the player inventory, and we initialize the list to be a new list, so we can add items to it. Like I said before with item, we've got the public boolean add item to the list. So it takes an item, and basically we get a value saying the weight, which the container would be if we added the current sum of all the weights of items in the container to the new one. And if it's less than or equal to the max capacity, then we add it to the container, and we set the game object to be not active anymore, and then we return true. Otherwise, we return false, and this get current container weight just as a float here. Basically, what it does, it goes through all the current items in the container and sums up their weights, and then returns that as a float. Yeah. Next up, we've got a drop item from container, which takes an integer for the index of the item. Basically, what it does, it gets the item and then removes it from the list, but stores it here first so we can still reference it. And then it just calls that create item in world method that we had on item here. And it just calls it with the position of the particular container that it is in. Next up, we have a method for player open inventory. This is just like for, I've got it linked to the I key at the moment, so when the player presses I, this method is called from the player controller. So I'll just show you here. If you put input key down, kick up .I, it controls the container class, the player container, because that's just a static reference to a player container. To a container, sorry, so it will always be just the one instance over all instances of the class. So singleton, basically. And we call player open inventory. So that basically just, if it's being drawn, then it will stop it being drawn. Otherwise, it will say draw it. So basically, it just inverts whatever draw me is. And if draw me is true, so if we're wanting to draw the inventory, then we go for call item monitor.me.get nearest container. And that will get the nearest container to the player as long as it is within a certain distance of the player. So we're not like getting something that's really far off, even though it's technically the nearest. And if we're setting draw me to false, then we're going to set the comparison container to null, just so we can't like glitch out and access a container that's miles away. But yeah. So next up, we have the onGUI method for drawing all this fun GUI stuff, which is kind of a pain, but whatever. So first off, we just check if draw me is true to see if we want to draw it or not. This is all the scaling stuff that I use, so I've gone over it before in tutorials, so basically, all it does is scales the GUI to be a particular resolution. So so in this particular instance, the original width and height is 1920 by 1080. So basically, it will, no matter what the resolution of the screen is, it will sort of think it's 1920 by 1080, and we can basically have hard-coded values instead. So I hope that makes sense, but yeah. So basically, we can have like actual values here as if it was a 1920 by 1080 screen, and no matter the resolution, they'll always appear in the same place at the same size. So yeah. So first off, we just draw a background box. I'm just using the default GUI stuff at the moment. Then we draw identity. This just basically is a string, a string in a box that contains the what is it? Like info on what inventory is, so player inventory, nearby items, whatever. And then we do a check here for the player inventory. Not player inventory, for the player index start. So if this is more than 8, if the player index is more than 8 items below or less than the the number of items in the container, then player index end is the player index start plus 8. So it's saying, all right, we're more than 8 items away, so we can just add 8 items to the end, and that will be the 8 items we're wanting to draw on the inventory screen at this current point. But if we were to say, if the player index start was only 2 items away from the items in container.count, then we just want to draw those 2 items rather than just add 8. So we just set it to be items in container.count. So this will allow us to sample the list of items, 8 items at a time. But if we've reached the end and there's like not a multiple of 8, it won't like bug out on us. It'll just get the remaining items off the list. And next up, we have item start pause. Basically, like I showed you here. Let's do this. We basically just draw items. So we draw an icon. We draw a box with the name of the item. We do a box for information on the item. So at this point, we've just got the weight. Sorry. And finally, we have buttons for functions. So in this case, we've only got drop item and add item to inventory and stuff. So yeah. So that's what that is. Right. So first off, we just draw a box. So this is just the background box for the item. Then we make a texture position rect. So this is just the rect for the texture. So you see here. Then we draw the texture from the texture in the item script, or instance of the script that's in the list. And we do the same for like the name, the item info, and the drop button. But in the drop button, we have to have it in a if statement. So if we press the button, then it will create the item in the world and remove it from the container and then just return, because the list will have changed. So we can't continue iterating through it. So we just have to return to wherever it returns to, and then begin redraw the inventory on the next frame, which is, it's fine. You don't need to worry about that. And then we add 80 here. And finally, we've got 2 buttons, which basically just increase or decrease the index start here based on based on which button is clicked. And that allows us to cycle through the inventory. So yeah, sorry. And then again, we have a similar bit here. Well, basically, it's functionally identical, but the actual GUI is moved over 950 pixels, and instead of using the container list, we use either itemmonitor.getNearbyItems, or I think in this case, or in this other bit here, which is, we use the comparison container.items in container. So we're just using different lists of items, but functionally it's the same. So I'll only go over it once. So yeah, so sorry, I forgot this bit at the start. If comparison container is null, so if there's no comparison container, then we just draw. What is it? We draw the items in here. So we use the item monitor script that I'll go over in a second to get a list of items that are near to the player, and then like functionally the same, except we're using other in the start for the indexes and stuff. We use that to draw to decide what items to draw out of the list of items. And then instead of having a drop item button, we just have an add to inventory button. And yeah, so I'll just quickly hover over all that, so if you want to copy it down, you can. And likewise with the, so on this else bit, it'll be, so there is a container to compare to. So instead of using just nearby items, we use a particular container. And we just have a GUI box with the game object name and the .s, apostrophe s items. And again, we're still using the other im start and end. We just draw all the stuff here, and then we transfer the player button here, and whatnot. So yeah, it's quite long, but it's not particularly complicated, I hope. So yeah, so there it is. Just copy it down or something. And I'll get onto the item monitor now. Okay, so next up we have an item monitor script. Basically what this is going to do is store references to all the active items in the overworld and all containers in the overworld. So yeah, so first off we have a singleton just to enable a reference to it easily. I've got a list of all the items in the world. That these will be all the items that the player could pick up in the world that aren't in containers or not active at the current point. I've got a list of containers, which is all containers in the world. And remember, containers is just like sort of a loose term. You know, technically an NPC is a container because it can hold items. So yeah, and we have a refresh timer. Basically, I just check every second for any new containers or items. This should probably be put in a coroutine or something. So I'll do that at some point. Well, for now it works, and it's not that big of a performance hit because we don't have that many items or containers. Okay, so first up, we just call it on start. We set the singleton in awake. On start, we call refresh item list and container refresh to make sure we have to populate the lists of items and containers. And then on update, we count the refresh timer down. If the refresh timer is less than or equal to 0, then we call refresh items and container refresh again, and then we reset the timer to 1. So it does that once a second. So next up, we've got a method for remove item from list, item I. Basically, it will, if items in world contains this item that's passed in, it will remove it from the list. And again, we have add item to the list I. So if a list doesn't already contain I, then it will add it to the items in world list. Then we've got refresh item list, which basically just uses find objects of type item to find all the items in the world. And for each of the items, if the item is active in the world, so items that are not active are usually in containers, so we don't need to reference them. So in that case, we can just add these items to the list, and we'll be good. And again, container refresh works on a similar premise. So we initialize the list of containers like we did with the items in world. We find objects and containers and store them in an array. And for each of the containers, if it's not the player inventory, then we add it to containers in world, because we don't want the player to be able to transfer things between the player's inventory and the player's inventory as two separate containers. That'd probably duplicate items actually, so you know, not a good thing. Sorry. Next up, we have get nearest container. This will basically return the nearest container to the player, provided that container is within 2 units of the player. Otherwise, it'll just return null. So we basically got a container to store the nearest container, and we've got a float distance from player, which is initialized to 99999, whatever. It just needs to be a really large number because you're pretty much guaranteed to have a number lower than it, so it doesn't really matter as long as it's a high number. And then it basically cycles through all the containers. It calls the distance here, so it stores the distance between the player. We use pathfinding.me.player.transform.position because we got just a player stored there, and the position of the container. So we store that as a float. And if this is less than the distance from the player, so chances are it will be less than 9 million odd, 10 million odd minus 1. It will store nearest container to be whatever container that was in the list, and store the distance of player to be the distance. And then it will repeat, and if it finds a container that's closer than the one it just stored, then it'll repeat the process until it's found the nearest container. Now, if this container is less than 2 units away from the player, it will return that container. Otherwise, it returns null. Basically, this is just so it can't access containers that be obviously out of reach. And hopefully it will stop it being particularly difficult to pick up items on the floor if they're near a container. Which would be kind of annoying to do, but whatever. I can imagine it being fiddly, you're trying to access the items on the floor and it opens a container, and that's something I'd want to avoid. Finally, the last method, which I can get rid of all this commented out code, is the get nearby items. And basically what this does is returns a list of all items within 4 units of the player. So basically we get a rep val, which is just a list of items. We go through all the items in the world, and if they are less than 4 units away from the player's position, then we add them to the return value list, and then we return the list. Simple. And just as a sort of debugging thing, I'm using this test input just as a demo class. We have a method to, we've got an array of game objects just for item prefabs. And then I've got a method to populate inventories of the NPCs and add them to the player. And add them to the inventory. So basically we just instantiate a random object from the list of prefabs at the container's position. We add the items to the inventory provided that it's not the player's inventory. And that's about it. That's called on start. And yeah. So that's pretty much it. So I'll just show you this again. So yeah, we can see here, we can see all the nearby items of the player we can cycle through. We can also access other containers, so we can get the player's inventory, which they have none of. They have no items actually, or is it just no? It was because we didn't refresh the other index value, which I should probably do at some point, but not today. So yeah, we can take items off the NPCs. We can then proceed to drop them on the floor here. And there you go. That was inventories. Items will come not next week, but possibly the week after, because I'd like to implement some basic stats like player health, whatever else. I'm not sure quite what at the moment, because that'll be a job for Sunday, but yeah. Just one quick thing I wanted to show you, if you didn't see my video earlier, or if you're just in it for tutorials. Steam. Go to Steam. I can Google loud or quiet, and my game Loud or Quiet is now on Steam. And it will be released on the 20th of November. And we've got trailers and screenshots and all that lovely shit. And I still need to do some stuff to release the application, so just ignore that, it's just developer stuff. It unlocks in 4 weeks. And yeah, this is my Steam page, so go check out Loud or Quiet. There'll be links in the description for Steam and itch.io, because itch.io has a demo of it, so yeah. That's pretty much it. So cheers for watching. Bye. Goodbye.